Hi folks. Today I'm going to teach you how to use Google Spreadsheets to calculate averages and mean absolute deviation in your data. So here I have a data set from a quick and easy experiment I ran. I was interested in the question of what is the fastest way for 7th graders to move across the basketball court. My hypothesis was that it would be faster for my 7th graders to run across the court than it would be for them to hop either on one foot or on both feet. And I collected some data from about 14 of my students. Now, in this experiment, I had an independent variable, what I was testing. That was the different ways in which my students moved, running, hopping on one foot, or hopping on both feet. And I had a dependent variable, that was what I measured, that was the student's velocity. Now, in this experiment, it's important to note that my question is about all 7th graders on the planet. I want to know what's the fastest way for 7th graders to move. But I did not measure all 7th graders. I measured what's called a sample of that overall population. So my sample is these 14 students, Sonia, Ella, Bryn, Pancho, etc. And my population is all possible 7th graders. So let's start by calculating some averages. Now, each of these students is really different. Some of them were pretty fast. Elizabeth and Pancho were really fast here. They were able to move at 4.06 and 4.29 meters per second. Other kids like Tallulah just kind of stood there and they didn't actually make it all the way across. So some of them are very slow. So we've got some variation in our data. If we're going to compare this, rather than comparing every single student in all 3 categories, it's easier to have one number that represents the whole category. So we're going to use averages for this. So if I want to calculate the average, normally what I would have to do if I was doing this by hand is I would add up all 14 of these velocities running, and then I would divide by 14, which is the number of students I measured. So I'd add all of them up, divide by 14, that would be my average. Spreadsheets makes this much easier. If I want to calculate this in a spreadsheet, all I have to do is click in the box that I want the average to be in, and I hit equals. You always begin a formula in a spreadsheet with an equal sign. I type the word average. Average is a keyword. It's what this is going to do. I type open parentheses, and then I'm going to highlight the data I want to average. Now, to highlight data in a spreadsheet, I start by clicking in the middle of one of these, and I actually hold my finger down, and then I slide my finger all the way down so that I'm highlighting that full data set. I release my finger, I close my parentheses, and I hit enter. It would also work for me to just type equals average open parentheses E2 colon, which means through E15, and that would calculate cell E2, which is this cell right here, all the way down through cell E15, which is this cell right here. So now I have my average. On average, students in this class ran at 3.41 meters per second. Now, if I want to calculate a whole bunch of averages, I could do that exact same process again, but there's also some shortcuts I could do. One shortcut is that Google Spreadsheets actually knows what I've been doing in the past, and it makes some predictions. So if I type equals, it actually suggests for me, hey, do you want to add these up? Do you want the sum of F2 through F15? Or do you want to average cells F2 through F15? And I actually want to average cells F2 through F15, so I could just click that, and it would calculate my average. Hit enter. I've got my average velocity hopping on one foot. That's 1.85. Another option is I could copy and paste this formula. So if I've got my first velocity highlighted, you can see I've got the blue outline of the cell, and in the bottom right-hand corner there's this little blue box. If I move my cursor over it, my cursor turns into a plus sign, and I can click and drag over to copy and paste that same formula over, and it'll go, I see, I'm supposed to be averaging the 14 cells above this. And if I release, there's my averages. So my average velocity for running was 3.41 meters per second, for hopping on one foot was 1.85 meters per second, and for hopping on both feet was 2.02 meters per second. Now, that's an accurate average for these 14 students. However, it is not an accurate average for all 7th graders on the planet. Because there is variation in this data, if I were to have just one more student, it would actually change my average. So in order to really think about this, I want to also think about how much my numbers tend to deviate from the average. And the tool we use for this is called mean absolute deviation, which is basically, on average, how much is each trial from the average. So how far is, say, my first trial, 3.28, from my average, 3.41? Well, that's about 0.13 away. How far is my second trial, 3.65, from my average, 3.41? Well, that's about 0.24 away. And I could figure out all of those deviations and then average them, and I would have the mean, the average, of my deviations. So that's called the mean absolute deviation. That can be a little bit tedious to calculate by hand, so instead I'm going to use the spreadsheet formula to do this. The spreadsheet formula for calculating mean absolute deviation is equal sign, AVE for average, DEV for deviation, because I'm calculating the average of my deviations, and then open parentheses, click on my first data point, hold that cursor down, highlight all my data. You'll notice I didn't highlight the average, just the data. I close my parentheses, I hit enter. So basically, calculating the mean absolute deviation works exactly the same way as calculating averages, except here I've got equals AVE DEV instead of equals average. And again, I can copy and paste that process over and have all of my mean absolute deviations. Now, every 7th grader is different. If I were to average 14 different 7th graders, I would have a different average. But what the mean absolute deviation tells me is that my average for all 7th graders, while it might not be exactly 3.41, is probably going to be something like 3.41 plus or minus 0.59, which means if I were to repeat this experiment with another 14 7th graders, I might not get the average of 3.41, but I'd probably get an average somewhere between 3.41 minus 0.59, which is 2.82, and 3.41 plus 0.59, which is 4.00. So I'm pretty sure if I were to repeat this experiment, I'd get an average somewhere in this range. The same thing is true for my velocity hopping on 1 foot. There I have 1.85 plus or minus 0.46, which means I'd probably have an average somewhere between 1.85 minus 0.46, which is 1.39, and 1.85 plus 0.46, which is 2.31. For my velocity hopping on both feet, I'd have 2.02 plus or minus 0.35, which is to say somewhere between 1.67 and 2.37. Now, the reason why this is useful is because it lets me compare these numbers more realistically. If I want to talk about all 7th graders, my average isn't really exactly 3.41. Instead, it's this range. Now, the good news is the ranges for the velocity running and the velocities hopping, they don't overlap at all. Even the slowest runners at 2.82, or the slowest I think my average for running could be, is still faster than the fastest I think my velocity hopping could be, either on 1 foot or on both feet. So I can confidently say that there is a statistically significant difference between the velocity of students running and the velocity of students hopping on either 1 foot or on both feet. However, if I compare the velocity of students that are hopping, and I think about hopping on 1 foot versus hopping on both feet, sure, my average for hopping on both feet was slightly bigger than my average for hopping on 1 foot, but once I take that variation into play, well, maybe my velocity hopping on 1 feet is as low as 1.39, and my velocity for hopping on both feet is as high as 2.37, so hopping on both feet could be faster, or maybe my velocity hopping on 1 foot is as high as 2.31, and my velocity hopping on both feet is as low as 1.67. So maybe it's faster to hop on 1 foot than it is to hop on both feet. When it comes down to it, I just can't say for sure which one is faster. So if I'm comparing my velocity hopping on 1 foot to my velocity hopping on both feet, I would have to say that there is not a statistically significant difference between these two averages. So I can't say for sure which one is faster.